Hello everyone. Another example related to Kirchhoff rules. It's similar to the one before where I have three batteries in this example. However, I'm using here quite big size resistors and it's in kilo ohm. That will make us expecting the current will be so small. It's going to be mostly in milliampere. That's one. The other element I added in this example is finding the potential difference between point A and B. So I'm trying to find how much is the voltage or the total potential difference for the middle branch. It's a different or it's an addition compared to other examples I solved in Kirchhoff rules. So the usual, we're gonna start by um, distributing our current. I'll pick junction A and I will say this is the current 1 and here I'll call this one is current 3 going through resistor 1. Okay, and for um, the middle branch it's gonna be second current. So let's just distribute that all over the place to make sure we're not missing any. That's the second current, and for here that's the third, the usual. Let's say this is high, low, positive and negative. This one the high voltage side, that's the low, and for this one here is the high, this is the low. It's up to you if you want to do that or not, so it's your decision. Now let's write the junction rule. So it's I1 plus I3, that will give us the second current. That's our first equation. Now let's decide the loop direction. I will pick this one to go loop 1, and for this one I'll go counterclockwise, and this is gonna be my loop 2. Okay, let's write the equation for loop 1, and it's gonna be, this time I will be starting from here, which is okay. I can start from anywhere in the loop as long as I go back or I come back to the same point. So I'll start, it's gonna be positive 70 minus 60 minus 3 kilo, sorry about this one, let's fix this. Here it's gonna be kilo, that's resistor 3 multiplied by current 2, and then coming back through resistor 2, it's 2 kilo multiplied by first current, that will equal 0. That will give us, if after rearranging, it's going to be 10 minus first current, and that's 0. That's our second equation. For loop 2, I will go counterclockwise starting from this point, and it's going to be 80 for kilo going through resistor 1 and multiplied by current 3 minus 60 volt, that's the second battery, then minus 3 kilo ohm, that's resistor 3 multiplied by the second current, and come back to 0. If we're gonna make it simpler, that will make us a 20 minus 4 kilo, let's trace this one quickly, it's a 4 kilo I3 minus 3 kilo ohm multiplied by the second current, and that's equal 0. That will be my third equation. As we did before, I can look carefully and see that my second current is the common one between the two, or like between the second and the third equation. And from here we can look that current 2 is already known. It is the total I1 plus I3. So I will substitute I2 in equation 2 and in equation 3 and expand whatever is required from the bracket, and that should give me these two equations. It's going to give me 10 minus 5 kilo multiplied by I1 minus 3 kilo ohm multiplied by the third current. That will equal 0. As we did before, I call it star. This is the new version of the second equation. Oh, like this one, it's now here, it's the star. Now let's try the third equation. After substitute the I2 and expand it, it will give me 20 minus 3 kilo I1. Let's fix this one, sorry. Minus 7 kilo multiplied by third current, and that will equal 0. And I will call this one the double star one. Okay, cool. So I know now my two equations. They will help me to solve and find one of the two currents, either the first current or the third current. Once again, we're going to do the addition and eliminate one of the two of these currents. So let's do this. And I will say I'm going to eliminate the first current. So this is here our target, the first current. Looking at them, we can say, okay, I can simply here multiply this one by minus 3 and multiply here with 5 and just do the addition. Just for checking, minus 3 multiplied by minus 5 kilo ohm, that will give us positive 15 kilo ohm multiplied by the first current. Here for this double star, it's a 5 minus 3 kilo, that gives me negative. So definitely it's a positive 15 minus 15, they will cancel each other. And the rest, we're going to do the math. That will give me 7t positive minus 26 kilo multiplied by the third current. That will equal 0. Okay. Now from here, I can do this. I3, or the third current, will be 70 divided on a 26 kilo ohm. That will give us 2.69 milliampere. Okay, as expected, the current will be really small in milliamps. So that's the third current. The current going through this branch here will be 2.69 milliamps around this side. And from here, I can use this value and place it in one of these equations, like the star or double star, to give me the value of current 1. So you pick which one you prefer. I could pick the top one, the star one, and and substitute the I3. You will find that the first current will give you gonna be 0.38 milliamps. Great. So we have first and third current. Now from the first equation here, I can find the current number 2, which is just the addition of these two. That will give me 3.08 milliamps. Okay, so these the three currents going through each resistor in this circuit. Okay. Now we're gonna try to find the second part of the question, which is how much is the potential difference between point A and B. So I am going through this part of the circuit. Okay, so let's do this together, and we can draw that part in a separate. So this is point A. So I am going through battery, a resistor, and that's part B. The battery, it was the second voltage, and it's 60 also, and this one was 3 kilo, or it was the second resistor. Now, to find the voltage or the potential difference in this branch, it's going this way. It's the difference between the voltage between A and B. So I am ending at B, starting from A. So here we have to go through the process, like through this line. I need to calculate how much is the total voltage in this branch. It's kind of like I'm taking part of Kirchhoff rules. So through the battery, I am entering from A to the other side. That will give me a negative 60. And the current we draw here was going downward. That was the current, and it was the second current in our side. So it's again here positive. So it will be minus whatever the resistor. It is 3 kilo multiplied by I2, which we found before. So it's minus 60 minus 310 to the power 3 multiplied by the second current, which was 3.07 milliamps. And just to do simple math here, it will be 69.23 volt. And it's going to be negative. Now, what does this negative mean? The negative means the potential at point A will be higher, or it is higher than the potential at point B. I can write that down. The negative means the potential at point A is higher than the potential at point B. That's why we have this negative sign. Okay. I hope you find this example useful. With applying again another example with 3 batteries but bigger resistance, and also add to this the voltage or the potential difference between 2 points in one of the branches, or for one of the branches of the circuit. Thank you.